We are moving away from rationals and we are going to graph exponential functions. So I know you've seen exponential functions, you've talked about exponential growth and decay, done word problems with those, looked at least the very basic graphs. So we're going to transform some of these today too. So your parent function for an exponential, f of x equals b to the x power. B is the base of the function. Okay, so there's actually an infinite amount of parent functions because the b can change and it's still just a basic exponential graph. They will all have the same basic shape, but the actual anchor points will change from each one of them. So let's think about what that would look like over here. So if I wanted to graph f of x equals 2 to the x, so b, the base is 2, right? If I substituted in 0 for x, what is 2 to the 0 power? What is anything to the 0 power? 1. Anything to the 0 power is 1. Make sense? Does that sound familiar? Okay, so if I substitute 0 in here, then I would give me 1. So 0, 1 is 1 point. If I substitute 1 in here, 2 to the first power is 2. So I'm going to go 1, 2. What if I substitute in a negative 1? What's 2 to the negative 1 power? Do you know that? 2 to the negative 1 power, well, the negative puts the 2 in the denominator, so that's just 1/2. You basically take the reciprocal, okay? So super easy, it's just 1/2. So when x is negative 1, I'm at 1/2. Is there any number that I could substitute in for x that would give me a negative output? Is there anything that's going to change the sign? There isn't, is there? So and there's also nothing that's going to give me 0. Like this is going to get smaller and smaller and smaller, but it's never going to actually make it to 0. So we have an asymptote right here at y equals 0. And this is what your exponential growth function looks like. So when we say that things grow exponentially, these are going to grow pretty quickly, right? Okay. So then this says when a is greater than 1 and b is greater than 1, there's no a here because we're just talking parent functions. So it's really just when the absolute value of b is greater than 1. The function is increasing like this, and it's called exponential growth. Okay. Let's look at what happens when it's less than 1. So I'm going to do the same. I'm going to go in the same order. We're going to substitute in 0. 1/2 to the 0 power is what? 1. Anything to the 0 power is 1. If I substitute in 1, 1/2 to the first power is just going to be 1/2. What if I use negative 1? What's 1/2 to the negative 1 power? 2, because it's the reciprocal, so negative 1, 2. And same thing, we're never going to make it to 0. There's not anything that negative could come out of that. So I have an asymptote right there, and my function looks like this. Okay. So if your base is greater than 1, it's growth. If it's less than 1, it's decay, when you're talking just the parent function, which is what we're looking at right now. In this case, the function is decreasing and it's exponential decay. Okay. Everybody okay with all that so far? All right, and that's some basic things about exponentials I think you should have definitely seen before. All right, so now let's talk about the number e. Yes, it's a letter, but it's a number. And that's something that should have been introduced to you last year with logs. We're going to talk a little bit more about where it comes from and what it means tomorrow, because it kind of goes with that lesson a little bit more. But just like pi is a number, e is a number. It is an irrational number. Meaning I can't make it into a fraction. It's going to go on forever, it doesn't repeat. It has an approximate value of 2.718, blah, blah, blah. Okay, so we're going to look at it as an estimate of 2.7. but about 2.718. Exponential functions with a base e are called natural base exponentials. So if I have e to the something, like if I have f of x equals e to the x. So e is just a number, so basically the b is e here. And many real-world applications of exponential functions use base e. Right. We are going to graph it over here and see what happens. So we know that e is about 2.71, oh, okay, that's not what I'm writing. 2.71, oh my God. 18, there we go. Which we're going to just 2.7 is what we will estimate it as. We're also going to need, so this is basically e to the first power, or e. E to the negative 1 power is 1 over e, and that's about 0.3678 blah, 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 which we will just estimate is at about 0.4. Because you can't get that accurate on these graphs anyway, right? But you have to have something to estimate it as. All right, so when we go to graph it, if I substitute into here, if I'm going to substitute in 0, e to the 0 power is 1 every time. If I substitute in 1, I get e, which is about 2.7, so it's about right there. Negative 1 will give me about 0.4, so it's a little less than a half right there. And just like the others, I have an asymptote, and my function looks like this. Okay. We're okay with that? Is this growth or decay? Growth. It's exponential growth. My domain, it's all real numbers, right? So negative infinity to infinity. My range, where do I start? 0. Go to 0 to infinity. Do I get to include 0? No, because I never actually make it. My y-intercept is something I plotted, so that's good. It's at 0, 1. My asymptote, it's a line. It's y equals 0 because it's a horizontal line. Then as x approaches infinity, f of x approaches infinity. As x approaches negative infinity, f of x approaches 0. Okay. We good with that? Awesome. All right, so let's look at our transformations before we get to graphing some of the others. So this says recall, meaning this is a review. It's actually a review of a review. So this is all the same shifts, except it uses h and k. I left it in there as h and k because we've been using c and d, but it really doesn't matter as long as you know what it does in, in that situation there. Okay, so let's look at these. It says identify the parent function. Okay, so this is a little bit more important in these than it has been in some of the others maybe, because you don't want to get the transformations mixed up with what's actually going on in here. So my parent function is going to be f of x equals, so the base of the exponential is 4, so this is 4 to the x power. Okay. And so not only do we want to do that, we want to sketch a little thing here. So since this is greater than 1, this is what my parent function looks like. Okay. Then it says to identify or describe the transformations rather. So the first thing we want to look at is how many transformations do we have? How many do you think there are? I see 4. I see the negative, then the 3, then the negative 2, then the negative 7, right? So I see 4. It's a little easier on these to tell if it affects x or y because all the x stuff is up in the exponent. So when I look at this negative, I know that it's a reflection, and it clearly doesn't affect x. It affects y, which means it's a reflection in which axis? X. Then the 3 is going to be a vertical what? Stretch. Good, because y does not lie. By 3. Then the 4 is not part, it's not a transformation because it is the function, right? So that 2 means I go which way? To the right 2, good, because x is still a big fat liar. And then 7 down 7. Okay. We all good with that? Right, sounds familiar. It's the same transformation, so that's good. All right, so let's look at number 2. We got f of x equals e to the x. E is greater than 1, so it's going to look something like that. How many transformations do you see? 3. Good. So I got 3 of them. That 4/3 is going to be a vertical what? Stretch, because it's greater than 1. Good. Vertical stretch by 4/3. That negative is a reflection in what? The y-axis. Very good. And 5 means up 5. Oh. Everybody good? Questions? All right, let's look at number 4. So my parent function is f of x equals 3/4 to the x power. And that has to be in parentheses, because if it's not, then your exponent only goes on the 3. It doesn't go on the 4, and that's not what we want. Now that's less than 1, which means this is exponential decay, so that's what the parent function would look like. And then how many transformations do you see? 3, you'll agree with that? I have a negative, I have a 3, I have a 2, and a negative 1. You're 4? Yeah. It's all good. All right, so this negative is a reflection in which axis? X. Okay. Now the 3/4 set is part of the function, so that's not a transformation. But then I have this 3, it's up there with x, so I know it's a horizontal something. It's a horizontal what? It is a dilation, but it was a compression or a stretch? Compression, good, because it is because x is a liar. And 1/3. What does that 2 mean I do? Left 2, good, and 1 is down 1. Any questions at all? Alrighty, then let's put all this together and graph some. All right, so first thing I want to do is write down my parent function, f of x equals 3 to the x power. And then my little graph would look something like this. Okay. So you could write down your anchor points if you want, but they're pretty easy to find, so I don't know that you necessarily need to. But I always do them in the same order. Actually, let's write down our transformations first. Sorry. How many transformations do I have? 2. So I'm going to go to the right 1, and I'm going to go down 4. All right, so my parent function, even if I don't draw it in the little sketch every time, I have an asymptote at y equals 0. What's going to affect my asymptote on my final graph, the only thing that affects it is a shift up or down. And so if we have an asymptote, we always want to draw those first, just like we did for rationals. So I have a shift down 4, which means that this is going to go from 0 to 1, 2, 3, 4 to negative 4, and that's where my asymptote is. Draw that in first, and that'll help you with your graph sum. Okay. So then I'm going to take my anchor points. I would always start with 0, 1, because it's going to be 0, 1 for all of them. So I'm putting my pencil at 0, 1. Then I'm going to go to the right 1, and down 1, 2, 3, 4. Then for this particular parent function, when x is 1, what is y? If I put 1 in there, it's just 3, right? When x is 1, y is 3, right? Okay, so I'm going to go to 1, 3. I'm right here. I'm going to go to the right 1 and down 4, and I'm right there. So then when x is negative 1, what's y? What's 3 to the negative 1 power? 1/3, exactly. So I'm going to go to negative 1, 1/3, which is about right there. I'm going to move to the right 1 and go down 1, 2, 3, 4. And then my graph looks like this. My domain is negative infinity to infinity. It will be on every single one of these. The range is what changes. My range, I start at negative 4 and I go to infinity. My y-intercept, I graphed it, but it's not a whole number, so I want to kind of think about what happened. Remember, we were at negative 1, 1/3. We moved to the right and down, so we're a third up from 4. Would you agree with that? So what is 4 minus a third? And it's okay, you can even give me a mixed number on this. 3 2/3? Makes sense. 3 2/3. So I get 0 and then negative 3 2/3. My asymptote is at y equals negative 4. As x approaches infinity, what does f of x approach? Infinity. And as x approaches negative infinity, f of x approaches what? Negative 4. Okay. What questions do you have on the graph? Anything? Okay. We are going to skip 2 and 3. We're going to move on to 4. So here's an E. An E was about what? 2.7. And then 1 over E is about 0.4. Okay, so those are values you got to know eventually in your head. All right. So f of x is equal to e to the x. And it's going to, the parent function looks like this. How many transformations do I have? 2. So I'm going to have a reflection in which axis? Y-axis. And then the 3 means up 3. So where is my asymptote? On the parent function, it's at y equals 0. I went up 3, so where is it going to be? 3. It's going to be at y equals 3. So regardless of the base, my first anchor point is going to be at 0, 1. So I put my pencil there. I reflected in the y-axis, but I'm on the y-axis, so that doesn't do anything. And I go up 1, 2, 3. Then my next one, when x is 1, y is e, which is about 2.7. So I'm going to start at 1 and then about 2.7. I reflect it in the y-axis, so I'm over here. And I go up 1, 2, 3. So I'm off the graph a little bit, but I'm going to plot it anyway. Then when I'm at negative 1, e to the negative power is 1 over e, which is about 0.4. So if we go to negative 1, about 0.4, reflected in y, and go up 1, 2, 3. And my graph looks like this. Domain, negative infinity to infinity for all of them. Range, where do I start? 3 and go to infinity. My y-intercept, it's something I plotted in, something easy to figure out. 1, 2, 3, 4, so it's at 0, 4. My asymptote, now this is a line, so we always state them as lines. My asymptote is at y equals 3. Then as x approaches infinity, f of x approaches 3, right? And as x approaches negative infinity, f of x approaches infinity. Right. What questions do you have? Anything? All right, we're going to get number 5 started together, and then I'll let you actually graph it. So I have my parent function would be f of x equals 1/3 to the x power. And it would look like this for the parent function. Okay. Now in the end it might be reflected and moved and whatever, but that's what I've got for the parent function to help me with my anchor points. How many transformations do I have? 3. So I have that negative is a reflection in the x-axis. That 2 is a horizontal what? Compression, good, by 1/2. And then the 1 means to the right one. Good. All right, so I don't have any shifts up or down, right? Which means my asymptote is right here. So you try and get that graph in there. All right, let's walk through this together. So I'm going to start with 0, 1. Put my pencil here. I'm going to reflect it in the x-axis, ends up right here. Horizontal compression by 1/2, nothing happens. I go to the right one. So that should be one of your points. 1, -1. Do we agree with that point? Want that one on there? Okay. So then for my parent function, when x is 1, what is y? 1/3. Good. So I'm going to go to 1, 1/3. I'm right here. I reflected in the x, so I'm down here at -1/3. Horizontal compression by 1/2, so I go to 1/2 right there, and then I move to the right one. I'm about right there. Does that point make sense? Okay. Then when x is -1, what is y? 3. Good. So I'm going to go to -1, 3. I'm right here. I reflect in x. Horizontal compression by 1/2. Move to the right 1. I'm right there. Okay. Do we agree with those? Got that? Awesome. Oh, see if I can't draw something through it. Okay. So let's fill out what we've got. Our domain is still -infinity to infinity. You know what? Look, here's something that's wrong with my graph, which can get you in trouble in delta math sometimes. See how, and I kind of curved it back this way, which means it's not actually going to be a function. So I'm going to fix that because I want to just do a bad job because it's supposed to be going out more like that. Okay. So -infinity to infinity. My range, I start at -infinity and go to 0. So remember, left to right, bottom to top, least to greatest, always. Y-intercept, am I going to have one? Like, is it eventually going to cross the y-axis? It has to because I don't have a vertical asymptote, right? So, I mean, it's going to keep going out here. So it will eventually, but I don't know what it is. We're going to have to figure it out. We'll do that in just 1 second. Asymptote, it's an equation. It's at y = 0. As x approaches infinity, f of x approaches what? 0. And as x approaches -infinity, f of x approaches -infinity. Okay, so my y-intercept, I have a y-intercept when what is 0? X. So if this is f of x, I can find f of 0 and just substitute it into that original. So I have negative and then 1/3 to the 2 times 0 minus 1 power. Right? So that gives me negative and then 1/3 to the -2 power, right? Because that's going to give me 2 times -1. All right, what is 1/3 to the -2 power? What does the negative do to the 1/3? It turns it into what? 3, right? It's the reciprocal. So the negative makes it 3, and when you have 3 squared, what's that? 9. So this is just -9. So your y-intercept is at 0, -9. What questions do you have? All right. You get, on number 6, get the parent function written out and sketched and write down your transformations. Then we'll check those and then we'll graph it together. Okay, so do we agree that we have a horizontal stretch by 3 because x is a big fat liar? Go to the left 2 and down 1. Okay, so where does that put my asymptote? -1. Very good. Y = -1. Right there. All right, so then let's talk anchor points. 0, 1 every time. 0, 1. Horizontal stretch by 3. Well, x is 0, so that does nothing. Then go to the left 2 and down 1. So I'm at that point right there. Then when x is 1, y is what? About what? 2.7. So I'm going to go to 1, about 2.7. Horizontal stretch by 3, so my x value is 1, it is now 3. Then I move to the left 2 and down 1, and I'm right there. Okay. Then when x is -1, I get 1 over e, which is about what? 0.4. So I'm at a -1, about 0.4. Horizontal stretch by 3, so it becomes -3. Then I go to the left 2 and down 1. So I'm right about there. So my graph looks... Finally got it straight, and then my badge messed it up. Okay. Something like that. So our domain, once again, for all of them, -infinity to infinity. Range, -1 to infinity. Y-intercept, I clearly have one, but I don't get to guess off the graph, so we're going to have to come back to that. And then my asymptote, y equals -1. Then as x approaches infinity, f of x approaches infinity. As x approaches -infinity, f of x approaches what? -1. Okay, so I'm going to come back to this y-intercept. I have a y-intercept when x is 0, so I want to find f of 0. That's going to give me e to the 1/3 power times 0 plus 2. All right, well, 0 plus 2 is about, well, it's not about anything. 0 plus 2 is 2. And then 2 times 1/3 is 2/3. So e to the 2/3 power. And that's the best you can do. I don't expect you to know what e to the 2/3 power is. We would want it in exact form. So my y-intercept is at 0 e to the 2/3 power. Now, I'm thinking from my graph, e to the 2/3 power is probably a little less than 1, right? That's what would make sense. So I think I have the decimal, yeah. So what it actually is, not that you would have to find it or it matters, but so you can kind of see on your graph how you can estimate it if you needed to, it's 0.9477. So a little less than 1. Okay, we good? What questions you got? Anything? You can do this, right? Yes, you can. Okay.